Alright, so for these we're asked to find the reference angle given. So remember that this is going to be, we start here at 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. So for my first angle where it says find the reference angle for 286, remember I'm going to start here at 0. Okay? So my beginning of my angle starts right here. That's my initial side. And then I'm going to come around 90 degrees, 180 degrees, and then 270 degrees. So if I take 286 and I subtract 270 degrees, the remainder is 16 degrees. So that means I'm going to come in about right here. Actually, I should probably do it this way. And that's not necessarily drawn exactly to scale, but this is going to be an additional 16 degrees. So from here to here is 16 degrees, and then from here to here is 270, and they add up to 286. So then what I need to figure out is what is my reference angle here. So this is actually going to draw a right triangle, right? I got to think more along the terms like this. Where this point right here is an x comma y. And of course, this length right here, from here to here, is my radius or hypotenuse. This is my y value from here to here. And this is my x value. Oh, I didn't like that line. From here to here. And so this is my 90-degree angle. But what is this right here in the middle here, this little angle here? Well, remember that it's 90 degrees minus my 16 degrees. And so we could just do that on the calculator just to make sure. Oops, we don't want that. So I'm going to say 90 minus the 16. And where I get that from is from here to here is 90 degrees, right? So I'm going to say from here to here is just 90 minus 16. That's 74 degrees. So then theta, theta is just 17 degrees. Or 74 degrees. So right in here is 74 degrees. And that's it. That's all you have to do to have the reference angle. And so from there we could solve the triangles, we could do whatever. So the values of these things are going to be the same. So let me give you an example. If I say sine of 286 degrees, I get this value. If I say sine of 74 degrees, actually it's negative 74 degrees. I get the same value. And you say, well, why is it negative? Remember that we're going in the negative direction. So it's really negative 90 plus 16, because from here to here is the negative direction, right? So one last thing to remember, this way is a positive angle, this way is a negative angle theta. Okay? Alright, let's do the last one. For this one, we're going to do 780. So it's the same thing before. 0, 90, 180 degrees, 270 degrees. And then this is 360. And then if you rotate around a second time, that's 720. So if I go around one full revolution, that's 360, plus a second revolution, that's 720. So 758 minus 720 equals 38 degrees. So I'm going to go another 38 degrees. This is 38 degrees. Okay. Same thing here. We could pull out our handy dandy calculators. Same thing. If I say sine of 758 degrees, now your calculator will get a little wonky after a while. Or if I say sine of 38 degrees, they're exactly the same thing. So I think I'm just going to take a screenshot of that so you guys can see that a little better. And that way you could see it in your notes. Okay, and that's it. That's how you do that for the non-acute angles.